Video lesson 12.3. So this is a coordinate proof, but we're going to focus on parallelograms and rectangles. So again, one of the most important things, as I stressed in previous videos, is you need to know the properties of the figures that you're talking about. So in order to prove a quadrilateral, in this case here, we've got specifically a parallelogram. We've got 4 ways that we can do that, all right? Those 4 ways are going to be completely dependent on what information you have. A lot of times you can do more than one way. You might even be able to do all 4 ways. You don't, just as long as you can get prove one of them, you know that it is in fact a parallelogram. So, what are the 4 ways? So the first one is using the distance formula. We can show that 2 pairs of opposite sides are congruent. You also have, you can use a slope formula to show that you have 2 pairs of opposite sides are parallel. Again, those are properties of parallelograms that are unique to them. The other one that is commonly used is, but you got to be careful, is that you can use the distance formula and the slope formula. You can do it as a combination and just show that one pair of opposite sides is both congruent and parallel. So it's congruent and it's parallel. So the key to that one, though, is that it's one pair of both things. If you notice the other ones, you have 2 pairs for this one, and you have 2 different pairs for this one. So you got to be very mindful of that third option. But it is helpful because a lot of times you don't have information for both pairs, so you can just use the one. The last one is using the midpoint formula to show that diagonals bisect each other, right? They would have the same midpoints. I personally like this one the most whenever I can. I just think it's the fastest out of all of them, because if you look, I've got to do 2 pairs of distance formulas. So that's 4 distance formulas. For here, I got to do 2 pairs of slope formulas. That's 4 total. Here, I've got to do distance and slope formulas. So that's 2 for distance, 2 for slope. For midpoint, I only got to do it for 2 lines, both diagonals. There's only 2 diagonals there, so you only have to do it twice. So this is by far the shortest way to do it. And again, the way I like to do it. Again, you may not necessarily always love doing it this way, but I personally like it that way. So whichever one, doesn't really matter. So let's look at example number 1. Because sometimes we don't have a choice. Sometimes they force us to kind of guide it through one way. So here it's saying, given this quadrilateral, RUST, and here's the points, prove that it's a parallelogram using coordinality of 2 pairs of opposite sides are congruent. So that would be option number 1, right? So 2 pairs of opposite sides congruent. So now they're forcing me to use that particular means of method there. So that's why you have to be able to do all 4 of these. Even though, like I said, I prefer to use number 4 whenever I can, but if this was the question, I wouldn't have a choice. I'd have to use that one. So let's do that. So that means I've got to find the distance of all 4 sides and show that opposite sides are congruent. So let's have to kind of squeeze this in here because we're going to have a lot. We're going to do 4 distance formulas all together. So let's do it. So we're going to do RU. All right, let's do that one first. So the distance formula for that one. Again, remember the distance formula is the difference in the x's squared plus the difference in the y squared. So we've got 0 minus -3 all squared plus what was that, 3 minus -2 all squared. Looks like my line got line in there, so just reline that. There we go. So that's going to be it's plus 3 squared is 9, plus that's going to be plus 2, which is 5 squared is 25. So that gives me radical 34. Let's do the one across. I like to try and do the pair so I can see what's going on. So ST, that's going to be 9 minus, what was it, 9 minus 6 squared plus 6 minus 1 squared. So that's going to be, that'll be 3 squared, which is 9. That's 5 squared, which is 25. So that's also going to get me 34. So you can see that those 2 are the same. So let's show the other side now too. I'll do these in light blue here. So we've got RS, and that's going to be 0 minus 9 squared plus 3 minus 6 squared. So that's negative 9 squared is 81. That's negative 3 squared, which is 9. So that's me grad 90. And TU would be our other side. So that's going to be 6 minus negative 2 squared plus 1 minus negative 2 all squared. So that's going to be, what is that going to be? 6. That was a 3. Minus 3, that's 9. So 9 squared is 81. Plus, this is going to be 1 plus 2 is 3. 3 squared is 9. Let's make this a little smaller, right? So that's radical 90 also. Now again, I could simplify these, but I don't need to because I just need to show that they're equal to each other. So here's what I've got. So again, I've got the information. You're not finished though until you tie everything together with the sentence. So you got to prove that it is. So here, right, these are the same. These are the same, right? So now to make a sentence that says all of that together. So, so we've got, RU is congruent to ST, and we've got RS is congruent to TU. So I should say since these are true, then quadrilateral RSTU is a parallelogram. Because, that's the key. Why is it? Because it has 2 pairs of opposite sides that are congruent. All right, so that's the key. You need to have that sentence. I had to squeeze it in there because we didn't have a lot of space, but you have to make sure that that sentence goes along. So I got to show what I did, right? State what it is. State what I'm trying to prove, right? So I've showed that 2 pairs of sides were congruent, right? And that it's a parallelogram, and the reason. So the reason is essentially one of these 4 statements, all right, with those. So you got to make sure you actually answer the question by making sure you put the conclusion there. Just the work is not going to get you full credit, all right? It's 99% of it, but you got to tie it all together with that conclusion sentence. All right, part B, using the midpoint formulas, find the midpoints of each RT and SU. Again, I'm just going to show you this one real quick. This is the one that I would have chose if I had my own option. I could have shown that this is in fact a parallelogram by using the diagonals in here. So just here, I'll just trace them here real quick. So those would be my diagonals. So if I can show that they intersect, right, if they have the same midpoints, that intersection is both the same midpoints for both of them, that means they bisect each other. So let's figure out that now. All right, so we got the midpoint. I'm going to abbreviate. Midpoint of RT. What's that going to be? So that's going to be, again, the average of the x's, average of the y's. So 0 plus 6 divided by 2. Those are my x's. I've got 3 plus 1 divided by 2 for my y's. That's going to give me 6 over 2 and 4 over 2. So that's going to be 3, 2. Midpoint of our other one, which was, what was that one? SU. That's going to be here. So we've got 9 plus negative 3 divided by 2. And 6 plus negative 2 divided by 2. That's my x's and my y's. So that's 6 over 2, and this is 4 over 2 also, which would give me the same 3, 2. So again, this and this are the same. So again, my conclusion sentence that ties this all together. So if I was doing this one like here, I would say, since the midpoint of SU is congruent to and this actually, so let's just say equal to RT, then RSTU is a parallelogram because, I'm going to abbreviate that, because, again, I'm basically saying this sentence here, right, that the diagonals are bisectors of each other. So because the diagonals are bisectors of each other. So that would be like my conclusion for that information. Okay, so again, I like that one, and you can see how in terms of work, it's definitely a little shorter. But again, you need to make sure you know it. But if there's an example like this where they asked you to do a specific way, I have no choice. So you gotta do that way. All right. Example number 2. I'm gonna let you guys try this one. So pause the video, try any one of those 4 options, whichever one you'd like. From there, I personally, I'm gonna do it with the midpoint formula, just so you guys can see that one. That's the one I like. I also think it's the fastest, but again, if you feel more comfortable doing it, doesn't matter. Your work should ultimately just reflect whatever portion you're doing. But I'm gonna give you guys an opportunity to kind of try that one on your own. So take a chance, pause the video right now, and try to do number 2. All right, so hopefully you had an opportunity to do this one on your own. Again, as you can see here in the work that I have done, I have proven that it is a parallelogram. My conclusion says since the midpoints of both MO and MP are the same, MNOP is a parallelogram because the diagonals bisect each other. So that's my conclusion. That's what I'm proving or answering the question. And the green part here is my work to support that. So I found the midpoint of MO to be 5/2, comma 2. I found the midpoint of NP to be 5/2, comma 2 as well. They are the same, therefore I know the diagonals bisect each other. One other thing, if you prefer, you could have written this as 2.5, comma 2. If you prefer, that's fine. Whichever version you want is fine. Decimals or fractions, I'm okay with that. With that being said, too, one other quick thing is notice I put a little graph sketch over here, right? I tried to sketch and graph the points. I did that to help visualize what my diagonals are going to be. But remember, the order matters here. So in this case, you have to go around the figure MNOP in that order. So you know that these two would be opposite each other, and those two would be opposite each other. So there would be my diagonals right there. So if you don't have to necessarily if you noticed it, but I like to do so just to make sure that I have the right points and the right idea of where it is. So again, there's no graph paper there, but a sketch doesn't hurt you. All right, the next one, then we'll wrap this video up here, is the rectangle. The same concept occurs here, but we're going to utilize the properties of a rectangle to do the same thing. So you do have to be a little careful here about these for a reason. I'll give you that in a second. But one of the first things, again, the properties that show that a rectangle is in fact the unique property of it would be that you have the slope formula to show that you have 4 right angles or 4 congruent angles. Now, if you already know it's a parallelogram, then all you would need to show is that consecutive angles are perpendicular, because in a parallelogram, we already know that opposite angles are congruent. So therefore, I can show that. So you can say all 4 right angles, or you can also say, that I have here. But again, if we already know it's a parallelogram, you already know that opposite angles are congruent. That's a property of them. So if you know that, then all you gotta do is show that the ones that are next to each other are also, aka consecutive, and that would be perpendicular. Because then if I have one perpendicular and opposites are equal, then all 4 of them are going to be perpendicular. The other one is showing the distance formula and the midpoint formula to show that diagonals are congruent to each other. Again, I like this one a little bit more often because, like I said, if I'm doing this from scratch, if I don't already know it's a parallelogram, the midpoint formula showing that they're congruent, that tells me it's a parallelogram, and then the distance formula would be from there. So I'm already kind of like halfway done if I'm showing that it's a parallelogram already. But again, if you already know it's parallelogram, then you just have to do the diagonals are congruent. So less work overall there. All right, so look at example number 3 here. So let's calculate slopes of all 4 sides in this example. So let's take that chance here. So I've got the slopes. So slope of EH. All right, so let's see here. If I go down and then over, that gives me a slope of -6/4. which would be -3/2. The slope of, I'm going to do the one across, so it should be the same as FG, right? So down over, that's also -6/4, so -3/2. So these are the same. That's good. Let's do the other one. So the slope of EF, that's going to be, we go up here and then over. That looks like up 6, right 9, or 2/3. And the slope of here, that would be, that's GH. That is also 2/3. All right, so right then and then, right, I now have here perpendicular and things here. So if I ask to prove here, it's just to show that it's a rectangle. So you've got a couple ways you can answer the question, right? I can say that, well, I have two pairs of opposite sides being parallel, which makes it a parallelogram. And therefore, I can just simply say then, well, I have one pair of right angles, therefore all 4 of them are right angles, is one thing. Or you can simply say that, you know, these two are perpendicular, these two are perpendicular, these two are perpendicular, and these two are perpendicular. Therefore, I have 4 right angles. Again, whichever way you want to write that, it kind of means the same thing. But that would be the idea, right? Again, you need to know that it's a parallelogram before you can know it's a rectangle. But all right, and just real quick to wrap up, here's your the work that I showed to prove that it's a rectangle. Again, I went with the idea of the diagonals, so I showed that the diagonals bisect each other because they have the same midpoints. So that's this part here and here. So this concludes that it's at least a parallelogram, right? And then I also came over here, showed that the diagonals were congruent to each other. So that's this part here and this part here, right, for those. So they have equal lengths. So therefore, I can say since quadrilateral ABCD has diagonals that are both bisectors of each other and congruent, then ABCD must be a rectangle. All right, so those are the kinds of ways you can do it. Obviously, there's more than one, but take the opportunity to kind of work through it and see which way you like to do it best for you. Just make sure you have the appropriate information for each of them. All right, and don't forget to utilize the practice problems for better understanding.